Good evening, everyone. It's a real pleasure to be here at the Global dotnet Conf. First of all, let me introduce myself. I'm Dongbing. I'm the lead of Avalonia China community, and I have been working on desktop applications at the large enterprises like Schlumberger and Nomura IT. And currently, I'm a Microsoft MVP in .NET, and I'm also a Avalonia MVP. For the past few years, I also served as the host and the organizer of dotnet Conf China. This year, our event will take place in Shanghai on November the 30th. So if you are coming to Shanghai, feel free to register and join the dotnet Conf China. And today, my topic is about headless testing for Avalonia application. I will explain the advantages of headless testing, the issues it addresses compared to traditional UI frameworks and the traditional UI automated testing, and why Avalonia supports headless testing, and how we can utilize AI toolings to build and test your application. So before that, we need to understand what is Avalonia. Avalonia is a cross-platform desktop UI framework that lets you build applications across different operating systems like Windows, Mac OS, Linux, and Android, iOS, and even WebAssembly. There's just all the major operating system or platforms that you can imagine. So over the past year, as Avalonia China community lead, I've been fortunate to see more and more large enterprises adopting Avalonia for their business projects. This has given me some fresh perspective on the challenges enterprise developers may overcome. For example, one enterprise came to me with a question. How do we do automated testing with Avalonia on embedded Linux? Honestly, that question stumped me at first, because most automation tests relies on the operating system's accessibility feature. And the embedded system distros obviously doesn't support that. So does that mean Avalonia lost another developer? Luckily, no, because I strongly recommended Avalonia's headless testing to them. And that's exactly what we are here and talking about this today. So here with headless testing, I'm not trying to find a regressive solution for the traditional automated testing, because Avalonia headless testing really have some advantages and features you should pay attention. And that will tremendously improve your application's quality. As you may be surprised, I'm still a full-time WPF developer right now. So I have to say, the automation testing for WPF application is very painful. And here are several reasons. First, the environment setup is really complex because you need to have desktop environment for the automation testing. And it relies on actual app running, right? So you need to prepare the end-to-end testing environment, or at least you should have some mocked service that you rely on. And second, every feature needs to be tested with the entire application running, which means the testing are all coupled together, and it's not every function can be tested individually. And three, engineers enjoy Windows so much that people usually forget that not all operating systems provide as good automation and accessibility support as Windows. So on some platforms, for example, the embedded Linux, the accessibility-based automation testing is just impossible. It simply won't work. And four, the traditional UI-based testing is very slow because you need to write your scripts, and usually you need to wait for 1 or 2 seconds after each action. And for complex applications, the tiny pieces of waiting time adds up to a really scary duration. My application in Nomura usually takes about 2 hours to finish an end-to-end testing. Yeah. So, actually, WPF developer already did a great job, because WPF is a MVVM framework. With good dependency injection, many developers can at least test the view model layer, right? So for business logic, we can get a very good test coverage. But for most UI-related features, people just giving up on testing. But in Avalonia, we are telling a different story because Avalonia gives us a brand new option that is headless testing. And first, headless testing is not something new. It's not a new concept created by Avalonia. So we need to clarify what headless testing is. Headless testing is an automated testing technique that executes simulated interactions in the background without requiring a GUI. For Avalonia applications, headless testing offers numerous advantages over traditional UI-based automated testing. First of all, it decouples from the graphics rendering process. So it doesn't rely on a physical display, a GPU, or a desktop environment. You can run it directly through the regular unit test project on a server. Second, without graphic rendering, it's actually much faster. For example, I have an open source project called Ursa. It's an Avalonia control library with more than 50 user controls. We have over 600 headless test cases, and a full test run on Ubuntu only takes 43 seconds. Yeah. And third, since it doesn't need rendering or think server, so you can seamlessly integrate your testing with the CI/CD. I think most CI/CD pipelines support it. I cannot find an exception. Yeah. So for Ursa, as an example, we use GitHub Actions for automated testing on a standard Ubuntu server. There's no desktop environment required at all. So why can Avalonia do this? While other frameworks like WinForms and WPF cannot do this, it comes down to Avalonia's architecture, and here are the reasons. First, Avalonia's rendering layer is completely decoupled from its core logic. So UI rendering is not tied to a specific desktop environment or display server. This lets us enable a headless rendering backend directly with no GUI. We just use code to simulate the UI rendering and the interaction. And in contrast, things like WPF and WinForm relies on the operating system for rendering, and they need a desktop environment to run tests. Even with things like RDP, you're just offloading the rendering to another machine. So that's still a desktop dependency. It's a fake headless testing, right? The second point is Avalonia actually provide a built-in headless testing SDK, which are the NuCat packages started with Avalonia headless, things like that. So this native support means no extra virtual display service or headless toolkit is required, while WPF and WinForm requires a third-party toolings like Appium or Piping Auto. The third point, Avalonia's architecture ensures a consistent operation and rendering across different platforms. So using a headless backend is identical to run your applications on Windows, macOS, and Linux. And the headless testing itself also behaves consistently across all the operating systems. So all this together make sure the headless testing on Avalonia application also ensures the quality of the real application running on desktop environment. So enough with the concepts. Let's look at the test cases from Ursa to see how Avalonia's headless testing works in practice and what we can test with Avalonia headless testing. And today we are using XUnit, but NUnit works too. You can find the detailed documentation on Avalonia's official website. Let's start with a common mistake many developers make. Earlier I mentioned Avalonia can run directly in unit test. So some developers may just create a blank unit test project and initialize a window here and call the window.show and expect something like the actual width is greater than 500 or something. And then they run the test and boom, you hit an error. So why? That's because while Avalonia controls don't need a real rendering backend, they still need some kind of required initialization of the core Avalonia services. So this error message will say the Avalonia iWindowing platform interface is not implemented. That's exactly what the Avalonia Headless SDK trying to resolve. It implements all the necessary services without relying on any system-specific rendering. So fixing this will only take several steps. Essentially, we just need to associate our test assembly with a test application to initialize all the required interfaces. And here's what we need to do. First of all, we need to create a test application. It is almost identical to the regular Avalonia application. Well, if you're testing an application, maybe you can reuse that. It depends on what kind of initialization you have in your actual app. But here's an important note. You'll still need to include a appropriate style in your application, because without them, even in headless mode, many template controls won't know their default template. So they will not show up in your virtual and your visual and logical tree. And second, create a test-specific app builder. The only requirement is to use Headless in your app builder. Here we can make a small comparison between the Headless app builder and the real app builder. A real Avalonia app would use things like use platform detect or more specific things like use Win32. But for Headless testing, we don't need to do that. We just include this use Headless, and that's it. And third, add the assembly attribute to specify the app builder as the entry point for Headless testing. Like this. And finally, for your actual test cases, instead of using fact attribute, we should use Avalonia fact attribute. And now, let's run the test again. As you can see, it will pass. And now, you might be wondering, what does Avalonia fact actually do to enable headless testing? It's actually very simple, the XUnit framework. Let's just run setup logic before test cases are created. So Avalonia fact just ensures a headless test session is initialized first, and then all tests run only after the session is ready. Okay, so let's have a quick recap of the setup process to make it clear. First, we need to create a test app. And second, we need to create a test app builder. And then we need to add the assembly attribute. These three steps are one-time setup for your entire test project. Once you are done, it's there. You don't need to touch them anymore. And finally, for different test cases, we need to replace the fact and the theory attribute with the Avalonia fact and the Avalonia theory attribute for every test cases. That's it. So once this setup is done, writing headless tests is almost identical to writing regular unit tests. Okay, our examples are now about the form control in Ursa. It has several common use cases. First, user can simplify the syntax to add a control directly from as form's child, while using an attached property to specify the label before the item. The second use case is that form actually supports accessibility. So clicking on this generated label will redirect the focus to its target, to its actual content. And also, if you define an access key here, it also works. You press the access key, it will focus on the item. And the third use case is the form supports basic MVVM. So if you define some view models to generate the items, the visual structure should be the same as long as you define some data templates. Okay, so let's work on these test cases. For the first one, we can just create a new user control to define the form. And in testing code, we set this view at the content of the new control and show the window. content at the new window and show the window. So ideally, it should generate the zero elements as I said before. So let's find all the labels in the zero descendants, and there should be 2. So one with content as name, and the one with the content as email. Let's run the test, and yes, the assertion is correct. Good. Let's move on to the second case to test. So forms should support accessibility. When I click on the label, the first text box should be focused. So let's find the position of the label relative to the window. And here, window provides a very handy method called mouse down, mouse up. As the name describes, it simulates the mouse actions from user. So we can click on the label with a tiny offset. Then we can assert that the first text box is focused. And yes, it is. Our assertion is correct. We can also use access key. Here, email has an underscore before E. That means we can press Alt and E to focus on the second one. So let's just call the window dot press key press QWERTY. Yeah. With the key E and the modifier Alt, and assert the second text box is focused while the first one probably lost the focus at this point. And yes, our assertion is correct. It works well. The third one is kind of complicated. We create another user control specific for this test case and write a view model for it. Here we define a collection, adding different types of view models to represent different types of items, and use the template selector to generate different items. So in test code, we show this user control and then find the form items in zero tree as expected. We have 3 items. The first one has the label name, and the child is text box, and so on. Yeah. So yes, all the test cases are fully tested. I feel really happy about this, right? By the way, we can check the overall testing coverage. Here I want to show the actual code in Ursa. This test is almost identical to what we have in previous demo. It covers about 80% of the code related to form and form item. Can you imagine a WPF control with 80% test coverage? I don't think that's gonna possible. But it's possible in Avalonia. Yeah. So in summary, with Avalonia headless testing, we can easily do testing for your UI for scenarios like basic UI specific functionalities, basic keyboard and mouse interactions, and some integration testing of UI and the associated view model. So all this can be tested with a very limited scope. Did you see that? It's very limited scope. You are testing exactly, focusing on exactly what you are testing. We don't need to run the entire application from scratch. Okay, so next, let's move on to some advanced usage of Avalonia headless testing. The first one is rendering in headless testing. Yes, even though we are saying headless testing doesn't require rendering, but actually you can render the UI. A typical scenario is to have a screenshot capture. Many automated tests need to take screenshots during the execution to review if the UI state is correct. And Avalonia's headless testing can do this too. Our earlier basic headless setup cannot do this. We need 2 extra steps to enable rendering. First is to include the Avalonia Ski and NuGet package. And second, we modify the app builder configuration like this. We use the Skia and disable the headless rendering. So with these changes, our headless tests will use Skia for rendering, and we still don't need a desktop environment. But we have the ability to render control with Skia. Let me find the example. Here, after we press the access key, we expect the second text box is focused. When it's focused, in semi-Avalonia theme, it should have a blue border. So is that correct? Let's call window.capture rendered frame. And we can save the Red Bull bitmap to a file. We check the status, and yes, it works as expected. Actually, in real world, if you need to, you can even predefine a screenshot as a baseline and then do pixel by pixel comparison in your testing to see if anything breaks between the updates. The second advanced usage is UI benchmarking. UI benchmarking is tricky because measuring execution time accurately is actually a big challenge. That's why this is a perfect test for Avalonia headless testing. Let's take the simple text block as an example. It's from our product. It's not open source, but I think it's a good example. This is a custom text block we developed specifically for displaying numbers. So it doesn't support line break, doesn't support trimming or font fallback. I stripped out all the features. So I'm pretty confident it would outperform the standard text block. But was that real? Is that the real case? We can test it with a benchmark project. Here in this standard benchmark.net project, we create a headless unit test session. Oh, actually, this is a session we create in XUnit, the attribute we have before. So we have this session, and the test involves in placing both a standard test block and our simple test block in the window, and continuously update their text content. And finally, we compare the memory usage and the execution time. And the result in version 11.3.7, our simple text block's average CPU usage was only 1/3 of the standard text block. And the memory allocation was just 60%. So as expected, it's more performant. It's very ideal for low power projects that require extreme optimizations on embedded devices. So yeah, seriously, without Avalonia's headless testing, I can't imagine how we can measure the effectiveness of such optimization. But with headless testing SDK, this task becomes surprisingly easy, right? Let me have a drink. Okay. Now let's quickly cover the scenarios where Avalonia headless testing is not suitable. That's also as important to know. First, regular headless testing cannot verify the actual visual appearance of a control. Like colors, how the color feels like, right? And what the font looks like. So for these cases, you will need to use the Skia integrated headless testing that we talked about before to capture the screenshot and do a visual inspection. And second, it cannot test cases that relies on specific hardware or rendering or display things. For example, if you need to test native control host or GPU interrupt, then headless testing is not for you. And third, some internal Avalonia interfaces and headless testing are highly optimized or simplified. For example, if we do not include Skia, all test glyphs are monospaced with no ligature, no glyph offset. So if you want to test some edge cases with unusual font layouts, then regular headless testing won't work. You need to integrate the Skia, as I mentioned before, to do the calculation of glyphs with half bars. And the fourth case, I think, headless testing is essentially software rendering. So system-level interaction and the native pop-ups cannot be simulated. So things like local file picker, dialogues, and the pop-ups that extends beyond the window bounds, this kind of feature cannot be tested in headless. So in real world, here's my recommendation to achieve the most reliable and efficient tests. That is to implement 4 types of testing for your desktop application. First is a unit test, focused on the view models and the control logic that's independent of Avalonia. The second is a headless test, core for testing UI functionalities. The third one is a render test. That is for the cases where you need to capture the screenshots and check the intermediate states. And the last one is the integration test or end-to-end testing that covers the scenarios that the first three cannot handle. So I'm pretty sure many of you are already panic seeing all these kind of tests, because I don't think any serious programmers have time to write so many tests. And you are right. 3 years ago, 3 years ago, I might accept this as a valid excuse for time consideration. But right now with AI toolings, that's no longer an excuse. AI-assisted testing is actually a perfect use case because the context here is extremely clear and specific. First of all, the context is guaranteed. We already have existing test code in our project as a reference. And also we have the control code we are going to test. Second, the goal is very clear. We need tests to pass, and we need sufficient test coverage. That's all very measurable. So given this, using AI to generate Avalonia headless test cases is practically a no-brainer. I'm serious. So let me briefly show you how we usually use GitHub Copilot for assisted testing. First, Copilot chat is a great starting point. We can ask it directly for help. I usually add some context. For example, I will select an existing test code snippet as a reference, and this way Copilot knows that I'm using XUnit, for example, and also I'm doing headless testing instead of a regular unit test. And then I will tell it to cover as much code as possible. Yeah, and sometimes I add some exclusions, like don't test the measure or range, that to exclude some methods. So once you craft a clear prompt, it guarantees to generate the test code right away. And the quality is actually really good. So what about the Copilot agent? It's actually even simpler. Let me walk you through some cases I had before. The first one is a pull request specific for testing. Here I raised a super simple issue, asking Copilot to generate unit tests or headless tests for all these controls, and nothing else. So let's review what the pull request is about. Copilot agent now successfully recognize the properties and method in my control and generate very comprehensive test cases. Here are two things I really like about GitHub Copilot generated tests. One, it generates many test cases that real developers will never write, like property get set. I don't think any developers would waste time writing things like this, but AI can do that for you. And two, AI is not perfect. It sometimes generates weird test cases and cannot match your expectation. But for me, it's a nice phenomenon because AI is just providing another point of view based on their understanding of your control. It may be useful to refresh your mind and detect some blind points of your design. So, thanks to GitHub Copilot, RSS overall test coverage increased from 10% to now 55%, I think. Another example is a recent pull request. Here I want to add some basic accessibility support in menu control, multi-combo box and tree combo box. So users can use keyboard navigations to focus on it and use keyboard to open and close the dropdown. Initially, I only expect Copilot to generate the code of the control functionality, but surprisingly, Copilot generates corresponding testing for me. That's because we mentioned in our Copilot instructions here. In common developed tasks, when adding new features, One of the requests is to add corresponding testing in the Headless testing project. Okay, so I think that's the end of my session. Thank you for much time today. We started by talking about the harsh reality of desktop UI testing and how Avalonia Headless testing resolved all the issues. We walked through the setup and the common test scenarios, some advanced tricks, and don't forget with UI tooling, with AI tooling like a GitHub Copilot, writing these test cases is no longer a time drain. The context is clear, the goal is concrete, and the AI turns the no time for test from an excuse into something optimized. So Avalonia's growth wouldn't be possible without the communities like you. So thank you so much for everyone here today. Thank you for pushing the cross-platform .NET desktop application forward. I encourage you to grab the Avalonia Headless SDK, fire up the Copilot, and write your Headless tests, experiment, and break things, and share your findings with the Avalonia community. Once again, thank you for being here. Happy testing and happy coding with Avalonia.